And this is just another example of I talked a little bit about the air tightness of a home. This is a comparison of a home, and these numbers were all taken from known manuals to do these calculations. If we took the exact same home, and so that it was made to about 1960s level of construction, a fairly loose home, and put it on Lake Ontario in an extremely exposed condition, 102,000 BTUs we need to heat that little home. At the very other end of the scale, we say that's an R2000 home, extremely tight. We put it in a sheltered environment, lots of other houses around it, not a whole lot of direct wind. We take that exact same house down to 38,000. And here's the real interesting thing. If you look at R2000, no matter what exposure category, we can hit that house with as much wind as we want. Those numbers all stay the same. Again, air tightness of a home is incredibly important. You can't spend enough money on acoustical sealing and tuck tape. It's a great investment.
And on that table now, where does the Leeds Platinum fall? Is that even clear?
This is just speaking to heat loss.
Okay.
So that lead home would likely be between these two.
Okay.
Maybe not quite R2000. It could be beyond that, depending on the choices that are made to get to that lead level. But it's certainly the higher end of the scale if you're looking at simple heat loss. And I know we're looking at photovoltaics and winds. We're looking at some electrical production tonight, so I just wanted to quickly demonstrate this. Again, that's a little bit difficult to see even from up here. If we look at the compact fluorescents, and this has been an argument that I've had with a lot of people, is that they are unenvironmentally friendly, they have mercury in them. And they do. But if we look at a standard 100-watt bulb, the equivalent compact fluorescent is 30 to 32 watts. The savings over the lifetime of that bulb, and I believe that's a 5-year lifetime cycle they're looking at, where are we here? $84 to $108, depending on what you're paying. Pays for a lot of light bulbs. If we look at the mercury content of that bulb, it's 5-year lifetime right there. It takes 4 milligrams of mercury in that bulb to make it work. In a 5-year period, it's going to use another 2.4 grams of mercury for the electrical production to power it. If we were to take an incandescent and power it from a coal-fired plant, a whole lot more. So yes, there is mercury in these, but it's less than what we're using to produce the electricity to light the incandescents. It's an argument that I've had a lot, and I thought it was worthy of putting it in there to sort of try to help people accept compact fluorescents as more viable options.
Are there LED lights coming?
Yes, and I've got a couple of them in my house. My wife loves it because I order things online and don't tell her about it. But I have a couple of them in my house, and I play with them just to see how they are. And certainly the LED lights are incredibly efficient. They've got lots of great technology in it. If I want the equivalent 100-watt glow in a globe form, I could be paying almost $200 for that bulb. If my wife asked, it was $20. But anyway, so it's very expensive. So your payback on that particular bulb takes a long time. Now, they last longer, but I would argue $200 a bulb, very difficult. You can get less expensive ones with less LED lights in them, but they're a very directional light. So they're great for task lighting. And in that application, I would say they're worthy of looking at. But for general lighting, they're still, the cost will come down over time, I'm sure. But I don't think it's there yet. And just speaking to the actual construction of the house, if we're looking at an off-grid system, and there are people in this room that know this a whole lot better than I do, I've just put this up here just to keep in mind while you're listening to everybody else who has more knowledge than I do speak. Heavier gauge wires have less line loss. If you're going to produce a lot of electricity and you want to reduce that line loss and use it more efficiently, and any electrician will tell you a heavier gauge wire is going to carry more current with less line loss, therefore you don't have to produce as much. Same idea with the distance travel between point A and point B. Typical house wiring by a lot of contractors is pull it and get it over there somehow or another, which is fine if we're doing standard construction. But if we're talking about producing it ourselves, we want to use it efficiently. So trying to map out how we're going to do it. Minimize circuit loads. So the more we add to that wire, the hotter that wire is going to get because it's got to carry more current. The hotter it gets, the more resistance it has, and then we have more loss. So again, mapping all these things out with somebody who's knowledgeable in that, and I'm not going to profess to be that person, but certainly asking these questions is a good thing to look at. Water conservation. again, Mike talked a little bit about this. I didn't get a chance to state it for his presentation, but I just wanted to touch on the water conservation in a home. If we pump, where I live, we pump the water. So if I have to pump that water, I have to produce the power to pump that water. The less water I pump, obviously, the less hydro I have to use. So looking at things, not so much in the power pipe, but the composting toilet where I don't use any water. This is a model that we do have in the house, and it is water-free. Low flush toilets are kind of the next step up, and Mike spoke about how much water you can use in a normal one, as well as a leaky flapper and all that fun stuff that goes on with it. Rainwater reuse, again, we're not pumping that water out. Rainwater capture, we're going to use the water, it's falling from the sky.
Are the composting toilets allowed yet in the city limits?
I don't know about the city limits. I can't think that they would be allowed. They are, under the Ontario Building Code, classed as a certain type, very specific type of septic system that's called a self-contained unit. So there is a vehicle in the building code to deal with it. I've never looked at it in the city limits as an issue, but I don't think that it would be an issue. There's stacks on them to carry the vent gases up, same as any house has, and that really would be the only issue. How you dispose of that compost afterwards might be an issue inside the city limits. It does have to compost for a further year before you can dispose of it, so that might be an issue for them, but I've never approached it. Jason, I don't know whether you guys have looked at that. Yeah, so our composting toilet came from Jason, by the way. And then the power pipe. This is always a neat little thing. All this does is, if it's in your house, you've got a stack, your shower water swirls on the inside of that pipe coming down. We're just going to take some of that waste heat going down the stack, preheat the hot water coming in before we dump it into the tank. Again, a great way to conserve some energy. If that heat's going to drain anyway, let's recapture some of that, put it back into the tank before we try to raise that temperature up from a very cold temperature.